import matplotlib.pyplot as plt percentage matplotlib inline. Import IO percentage CD we have already worked on the seasonal data, right? We have already worked on that seasonal flu vaccination, right? So we will we'll copy from there only. Vaccine train. Vaccine test. Vaccine labels. Or you can open the notebook again and create a new copy and do it also. Create a new copy or save it in a different location, and then we'll do it. Yeah, both train and test. No, you open the old notebook and then you delete from what you call I'll send this notebook. Or I'll send the updated notebook.
Oh.
I'll show you. What the hell, yeah. I've sent you the notebook. You can guys download. And you change the folder path, IO path, okay? And then you can run the notebook. So earlier we worked on seasonal vaccine. Right? So there are two dependent variables. One, seasonal underscore vaccine, which is a balanced data. Why we call it balanced data? So vaccine labels dot seasonal underscore things dot value underscore counts. Now here 0, 1 are almost close. Here 0 and 1 are almost close. Right? They are almost close. Whereas if you look at the second dependent variable, which is the H1N1 underscore vaccine, we call this as imbalanced data. Why? Because vaccine labels dot H1 underscore vaccine dot value underscore counts. See, look at the students. There are imbalanced data as there is huge difference between counts of 0 and 1. Got it? 21,000, 4 times more. 5,674 only once. 4 times more are 21,000. That we call it as imbalanced data. Balanced data means here almost both of them are closer to one another. Maybe 60-40. 60-40, that's okay. But here it is how much? 99, 98 and 2%. That's a huge difference, which is a imbalanced data. So this concept, we call it as imbalanced data. Yeah. Just run the notebook with your thing and then you run these two columns. Maybe you have see, most of the classification problems will have this problem. So now we will see how to deal with the classification. Only with the classification. This problem is with only classification data. Previous model, when the imbalance data is there, we have a problem. What problem we get, we will discuss. And change the path. You have to put double quotes. Online guys, Windows guys, see percentage CD double quotes. Because in this case, we don't have train data. Train data dependent variable is separate. Dependent variables are in separate file. Vaccine labels. So what I did was in the train data, I put an ID column called train, and in test data, I put an ID column called test, so that we can separate them later after pre-processing. Online guys, all of you got the file and you have run. All right, can we move forward? Added the column ID because train data में dependent variable नहीं है. हाँ, split भी कर सकते थे, but to avoid the unnecessary things, we put an additional column called ID, and then we did. Otherwise, you can do normal splitting also based on row numbers. See, most of the times you see classification problems as imbalanced data only, like HR analytics is an imbalanced data. What is the other one we worked on? Imbalanced data. See, this H1N1 is imbalanced data. Telecom churn is also there, one data where we have too many nodes and very less. Yes, that is also imbalance data. So imbalance in dependent variable. What happens is imbalance in dependent variable. We are bothered about imbalance of classes in dependent variable Y. The whole imbalance problem is related to dependent variable. The whole imbalance is related to dependent variable Y. If there is imbalance in independent variables, we are not bothered. We are bothered only if it is Y. What is the bothering? What is the problem here? What is the problem we are going to face? Let us say Y is equal to vaccine labels dot H1N1 vaccine, X is equal to vaccine train DF. Our dependent variable is H1N1 vaccine and our independent variable is vaccine train DF. Now, this is a classification problem. So it's a classification problem. Classification problem as dependent variable is non-numeric and binary. Okay. Now, when it is a classification problem, what we will do? Logistic regression from sklearn dot linear underscore model, import logistic regression. We'll import logistic regression. Logit is equal to logistic regression. Logit model is equal to logit dot fit X comma Y. So iterations are not enough, so we will add the iterations argument. Max underscore iter is equal to 2000. Now it has fit. Logit model dot score X comma Y. So if you see the score, we got an accuracy of 0.8433. We got an accuracy of 0.8433. Okay. It looks good. It looks good. Now let us plot the confusion matrix. Logit predict is equal to logit model dot predict of X. Now PD dot crosstab Y comma logit predict. See, 3100, 1083. The misclassifications are there. We have misclassifications of 3100 and 1083. Now, what is the effect of these misclassifications? Now we can find the effect of misclassifications using various metrics. You remember confusion matrix? Accuracy, sensitivity, specificity, recall, F1 score, precision. All these metrics are there in confusion matrix. Now, you can see from the confusion matrix that the false positives and the false negatives are significant in number. The false positives and false negatives are significant in number. Right? If you look at our data, the cross confusion matrix, there is good amount of false positives and false negatives. But if you put the classification report from sklearn dot metrics import classification report, print classification report of y comma logit predict. Now, what do you observe from this classification report? Yes. Look at the F1 score, precision, and recall of minority class. Minority class means that here the minority class is 1, which has less number of observations. Majority class is 0, because it has 21,000 observations. Look at the minority class precision, recall, and F1 score. They are very, very bad. What did I say? All metrics should be above 0.70. All the metrics in confusion matrix, including accuracy, should be above 0.70 till 0.95. But what is happening with the minority class? Majority class is good. Majority class is absolutely being predicted correctly. But what about the minority class? It is predicted very bad. And overall accuracy is good. So if you look at it, overall accuracy is good. Overall accuracy is good, but the precision, recall, and F1 score of minority class, which in this case is 1, is very bad. Majority class, which is 0, is good. Majority class is good, but minority class is very bad. And what we are bothered about here? We are bothered about here minority class only, no? We want people to take vaccine, right? We want to encourage them to take. So in this case, in most of the classification problems, minority class is what we are interested in. Is underscore promoted? Yes. We want to know why people are getting promoted. So minority class plays a very important role. Now, if you recall, or the other name of recall is sensitivity. What is the formula? True positive divided by true positive plus false negative. Correct only, right? So I know people get confused. Even sometimes I get confused. See, TP by TP plus FN, sensitivity, right? Precision is TP by TP plus FP. Precision is TP by TP plus FP. What is F1 score? Precision is good. But what about the other two? Other two are bad, right? 2 into precision into recall by precision plus recall. So whenever you're working on imbalanced data, along with accuracy, you should also focus on these three metrics of minority class. Your focus should be accuracy plus minority class, precision, recall, and F1 score. Okay. So that is overall accuracy will always be good. Overall accuracy will always be good. But these three metrics will be bad for minority class. That is the problem in classification models. All right, guys, can I move forward? Yeah. All right. Now, to deal with imbalance, we have to use resampling techniques. Resampling techniques have to be used. The first technique is undersampling. The first technique is undersampling. Random undersampling removes randomly selected removes randomly selected records or observations from majority class to equate it to minority class. It randomly deletes or removes observations from majority class to equate it with minority class. This will lead to loss of information. It will lead to loss of information and should be implemented if there is a very large data. This is preferred when you have very, very large data. So random undersampling removes or deletes observations or rows from the majority class to equate it with the minority class. It leads to loss of information. It should be implemented only if you have very large data. The other method is oversampling. I'll give. We will see. We will see how it works. Whether it works or not, we will see. Random oversampling duplicates or copies randomly selected rows or observations from minority class and equates to majority class. Now, this leads to overfitting problem, and we will implement only if data size is small. We will implement this only if the data size is small. Here. So blue is the majority class, deleted thing, and it is made equal to orange class. Orange is the minority class. This is called undersampling. Oversampling, orange is the minority class. You copy and duplicate the rows and equate it to the majority class. You'll copy and duplicate again and again, repeat the rows in case of oversampling. We'll see. We'll work on. We have our data now. We'll learn it hands-on. Sometimes it differs, sometimes what you're saying is right. Sometimes it depends on the data, what we are dealing with. Copy may see, when you're copying skewed data or something like that, then it's a problem, right? Your data is numerical in nature and the independent variables have skewness and kurtosis or outliers. And if you're copying them and again, will your model accuracy will be there? It will have an effect on the model, right? So we need to understand how the model behaves. There is no way we can say that it will always work in the right manner and it will always not work in the manner. It all depends on the data. See, that's what we have a problem in data. In normal software projects, the objective is, the data is predefined, the objective is also clearly stated. But in data, the data constantly changes. And sometimes what happens is, you have built a model on one set of data with X variables. Next time you get a data, you will have new variables. Now, if you have new variables and old variables, that's very easy for you. You can add these new variables to the model and you can restructure your model. But if there are some variables which are deleted and new models variables are added, then you have to have a problem. You have to completely start from beginning. So all these things will happen in data. So we cannot say which technique will work with. It's all about trial and error method. We will run this on the data and then see how it behaves. Now, there are certain statistical models. Statistical models for imbalance data. The most prominent one is SMOTE, which is synthetic minority oversampling technique. This is a very popular technique, SMOTE, synthetic minority oversampling technique. We have also one more technique called rows, which is again random oversampling technique, which is particularly there in R software. Now the difference is it oversamples both classes. See, in this case, we are oversampling only one class, right? Minority class. Whereas the rows algorithm will oversample both the classes, both the majority as well as minority class. That algorithm as of now is available in R only. It is not available in Python. It is being implemented, developed in Python. We will get it in future. Rows algorithm. Rows is as of now available in Python, R only. Then we have something called Tomek links. Tomek links are groups of similar data on either side of the class. On either side. Groups of similar data on either side. Pip install Imbalance. Okay, you are able to install IMB Learn. It's a small library only. From Imbalance dot undersampling, import random undersampler. Rus is equal to random undersampler, random underscore state is equal to 42. So that we all have the same data, we are fixing the random state. X underscore Rus, comma, Y underscore Rus is equal to Rus dot fit underscore resample X comma Y. Print Y dot value underscore counts coming. Access is given. What permissions we are given? Users normal Anaconda we are denied permissions. Google, not make this. First one, go to the first one. No, this would not. So, after example, Google Wizard. IMB Learn and Anaconda Python. First one open to Anaconda from future. So, our first line for Anaconda from go to this Windows Anaconda folder. Go to Anaconda folder. And you don't do that. When you don't know the correct one, go here, use the folder, Anaconda from. Right. Now paste it, control and put that and Actually, आपको यहाँ पे वाइट करना पड़ेगा, आपको नीचे मार्क दे रहा है, ठीक है। जनरली यहाँ पे स्मॉल वे आपको डालना पड़ेगा, वही नॉन कैंसिल मारोगे तो कुछ हो गया। ये डिलीट करो। डन करो। Okay, we can see now here 5674, 5674. Both classes are 567. Initially 21,033. Now it became 5674 by random deletion of rows. Now build the model. Logit model or logit underscore rus is equal to logit dot fed x underscore rus comma y underscore rus. Logit underscore rus dot score x underscore rus comma y underscore rus. 7752. Accuracy has reduced. Initial accuracy 84 ना, अभी accuracy कम हुआ है. Now logit underscore rus underscore predict is equal to logit underscore rus dot predict x underscore rus. Print classification report y underscore rus comma logit rus predict. Now you see the metrics. Now you see the classification. तो आप ना हमेशा कोंडा इंस्टॉल ही करो, पिप इंस्टॉल मत करो, ठीक है? You always do conda install. Random statements we are fixing the random ना, random हर एक का अलग रहेगा. अगर if you don't fix the random state, your random selection will be different, my random selection is different. By putting 42, all of us will have the same random selection. Otherwise, each of us will have different random selections. So random underscore state आप fix करोगे तो everybody will have the same. And you have to give the same number, 42 or 123 or any number. No. Default is 0. See, almost all algorithms will have random state. In both, in R we call it as set seed, set.seed. In R we call it as set.seed. But R में क्या है कि इतना change नहीं आएगा random number में. But in Python, random numbers for two people will be very, very different. In Python, we have seen that problem. Huge difference in random number generations. So if you look at the classification report, you can see, right, all the metrics are very good. They are very close to one another. They are very, very good. Can you scroll down? Overall accuracy is reduced, but all the metrics are very close to one another. This is a robust model for prediction. See, sometimes you have to sacrifice accuracy. For a better model in real-time data science, you will be very happy to get accuracy between 70 to 80. Because most of the times we see you get very worst accuracies, 30, 40 like that. Bringing it above 70 itself will take a lot of time. Lot of variable selections, lot of what you call playing with the data and all. And still the rate is 50%. 50% only of the times you will find a good model with good metrics. Rest of the time you have to play with the data. You have to play with the data. And a lot of methods are there. Which one? For combining models, in Python, you have to write a code. But the problem is, if you are combining models, the variables should be same. So, stacked models, we call it as stacked ensembles. You can combine models. Stacked ensembles बोलते हैं. उसमें क्या है कि weighted average लेते हैं. Prediction का weighted average ले सकते हो. 20% of first model, 20% or 80% of the second model, and you build a new prediction. That is called stacked ensemblings. So there are different methodologies in stacked ensemblings. You can do weighted averages. You can take equal weightages of all predictions. So model built करने के बाद, predict करने के बाद, you can do the stacked ensembles. You will see in Kaggle, a lot of people do that. 30% of XG boost, 30% of LG, light gradient boosting, 30% of CAT boost, and 10% of gradient boost prediction. And they'll come up with a new prediction. That will obviously will have a good rank. So people do that way. But in industry, we can't do all those things because computing power is limited. No? See, the biggest problem you will face in industry is computing power. अगर आप क्लाइंट के पास जाओगे बोलोगे कि I need computing power and computing power के लिए 2 लाख या 3 लाख हर महीने लगेगा, तो he will say no. आप क्लाउड पे रन करोगे ना, क्लाउड में क्या है कि प्रोसेसर को रेंट किया जाता है. आपको 6 GB बाय डिफॉल्ट मिलता है. आपका अगर 13 GB रैम चाहिए या 20 GB रैम चाहिए, आपको एक्स्ट्रा पे करना पड़ेगा. उस एक्स्ट्रा पेमेंट होगा मंथली बेसिस पे होगा. मंथली बेसिस मतलब हर महीने के लिए आपको 3 एडिशनल प्रोसेसेस चाहिए. एक प्रोसेस का 30,000 लगेगा. 90,000 पर मंथ आपको पे करना पड़ेगा. बिग डेटा, बिकॉज इन रियल टाइम यू विल बी वर्किंग बिग डेटा ओनली. जो आप रियल टाइम में जाओगे ना, इट विल बी ऑलवेज बिग डेटा एंड यू विल बी वर्किंग ऑन Azure, AWS और GCP, not on your system. Azure, AWS और GCP, जो भी क्लाउड कंपनी ने किया है उसमें आप काम करोगे. उसमें आपको पाइथन और जुपिटर नोटबुक भी मिलेगा, सेम थिंग, बट इट इज नॉट नेटिव. उसमें क्या है कि प्रोसेसिंग फिक्स्ड रहेगा, जो डिफॉल्ट प्रोसेसिंग मिलता है बेस मॉडल के साथ वो आपको कम मिलेगा। प्रॉब्लम यह है कि वहां पे स्टोरेज भी आपको देखना पड़ेगा ना, स्टोरेज के लिए भी पे करना पड़ेगा, प्रोसेसर के लिए भी पे करना पड़ेगा, क्लाउड में स्टोरेज के लिए भी पे करना पड़ेगा। You have to pay for both storage as well as for processor. That is the problem in cloud. So storage cost already will be there because you have to bring data from the database, store it in a storage bucket. We call it as Kubernetes or something like that. You have to store it on S3 bucket or Kubernetes bucket in cloud. And then you build models in another storage, in another processor or RAM. And then you connect the processor to the storage to get the models. So ये सब करने के लिए आपको if you are familiar you can do it, or you will have DevOps. जो DevOps people will be there, na, they will help you to do that. You have to tell them how much of space you need, वो space create करेगा. Then you have to write your own SQL query, Hive query or any other PostgreSQL. You write it and bring the data and put it in that thing. And he will also allocate the processor to you. And based on the processor allocation, you run the models, finalize the model, and you tell them. He will implement it in Python. So over a period of time, we will only do it. DevOps, it's very simple. Everything is automated in cloud. There is no coding in cloud. It's all automated. So you can also do it on your own. First 2 iterations के बाद आप खुद ही कर लोगे. That's what I have seen from PG18 girls. They said nothing. We are doing our own thing. We don't need any cloud ML. They have learned ML ops and DevOps on their own, and they are implementing models on their own. So,
sir, what is Azure, sir?
Azure,
sir. What is Azure?
Azure is Microsoft's cloud. Microsoft's cloud is called Azure.
Okay, sir.
Azure is Microsoft's cloud offering. Azure is Microsoft, AWS is Amazon, and GCP is Google Cloud. So these are the 3 important cloud platforms in the market right now. Azure is number 1, followed by AWS, followed by GCP.
Okay, sir.
Okay. So initially, Azure and AWS are very, very powerful in terms of doing a lot of analytics, and GCP is sticking to the app-based platforms, creating applications and all. GCP is very better. AWS and Azure is very, very good. Amazon, Microsoft, and GCP, they are dominating the cloud, the 3 people who have the monopoly. Okay, all of you have done this. So we have seen random undersampling has given us very, very good score. Now let us run from Imbalance dot oversampling import random oversampler. ROS is equal to random oversampler, random state is equal to 42. X underscore ROS, comma, Y underscore ROS is equal to ROS dot fit underscore resample X, comma, Y. Print Y dot value underscore counts, print Y underscore ROS dot value underscore counts. Build a logistic regression model on ROS and see how the model performs with ROS random undersample. So what's the score? Online, we have 4. 7, 3 are absent.
Saturday you have classes? Saturday. Because Saturday is not available.
Tuesdays I am not available.
Tuesday is not available, so you have to, yeah. Tuesday is not available.
So I am available Monday, Wednesday and Friday.
Yeah. So to cover that, we will plan for Saturdays. Okay. Friday.
Monday, Wednesday, Friday and Saturday.
Right, 4 days in a week. This is what. If I'm not doing this, I will not do the leadership and the course is the problem. So cover it up. Now, can you cover it? ठीक है देखेंगे वो तो मेरे को तुम्हारा मतलब बोला
Monday, Wednesday, and Friday and Saturday.
will take only couple.
Okay. Same only, right? Logit underscore Ross is equal to logit dot fit x underscore Ross comma y underscore Ross. Logit underscore Ross dot score x underscore Ross comma y underscore Ross. 77.49. What was the earlier accuracy? 77.52. It's almost marginally same. Logit underscore Ross underscore predict is equal to logit underscore Ross dot predict of x underscore Ross. Print classification report y underscore Ross comma logit Ross predict. 77, 76, 78, 79, 75, 77. Any difference? 76, 80, 78. 76, 80, 75. So both are exactly same. Now let us look at the statistical model. Let us look at the statistical model. The statistical model or the method which is used in industry is synthetic minority oversampling technique. This is a very prominent method which is used in banking, financial services and all. See, in banking data, we will have imbalance. Credit card default will be less than 5%, right? 95% will pay the credit card bills. Only 5% will default, imbalance data. Loan default, 92% will pay, only 8% will default. Loan approval rate, okay. 70, 20, 80, 30, 70, 30, okay. 70 loans are approved, 30 are rejected. There you might not see much of a problem, but the defaults and frauds is where you will see a very, very small number. So that is where this SMOTE is used. Now, SMOTE uses Canaan's methodology using the Euclidean distance and creates synthetic or artificial data. It creates synthetic or artificial data which lies within the range, and do not create outliers. See, SMOTE creates new data points, artificial data points or synthetic data points. In oversampling, what we are doing, we are copying and pasting the rows. We are simply copying and pasting the rows, thereby we are increasing the same sample. Here it is not like that. It will create new data. It creates new or artificial data or synthetic data, and then it will oversample. Now, how it creates? It uses the Canaan's Euclidean methodology, and it also uses random number generator It also uses the random generator for randomly selecting weights in range of 0 and 1. But in real time, it might be even smaller. It will be a random weights will also be assigned. Let us say we have two independent variables. I have two independent variables, x1, which is age, and x2, which is income. I have two independent variables, x1, which is age, the x2 is income. Now, x1, these are the data points I have, 46, 34, 50, 52, 28, like that. For x2, income, $3,500, $2,800, $4,000, $4,100, and $2,500. I have two independent variables with observation. Okay, now it will choose a random weight between 0 and 1. So I have randomly selected 0.60. I have randomly selected 0.60. So what it will do is, let us say we have two data points, 2,000, 3,500 and 2,800. $2,800 plus 0.60 into 3,500 minus 2,800. You'll get a value. Oh, what happened? Float object is not callable. Oh, sorry. Forgot into. So we got 3,220. 3,220. So a synthetic data point. Do you see 3,220 in our data? Is 3,220 there in our data? No, right? But it is within the range. The max is 4,100, the min is 2,500. Within the range, it created a new data point called 3,220. Similarly, for the other variable, let us say 46 plus 0.60 into 34 plus 46 minus 34. This is 41.2 or 41. So you got a new synthetic data points. So the new synthetic data (3,220, 41). So this is how it will find the closest observations and uses those closest observations to calculate a new data point. It will automatically. There is a function. There is a function automatically. Now I'm showing the manual calculation, how it is done. for your understanding. Okay, so there are different types of SMOTE. SMOTE NC. SMOTE for both numerical, continuous, and categorical variables or features. We have a function called, there is a SMOTE also there, SMOTE NC is also there, and SMOTE N is also there. This is a SMOTE variant only for categorical features only. Basic SMOTE works only on numeric data only. So we have a basic SMOTE function which will work only on numeric data. We have SMOTE NC, which works both on numerical, continuous, and categorical variables or features. And SMOTE N is for categorical features only. So there are three different versions of SMOTE available in Python. Basic SMOTE, SMOTE NC, and SMOTE N. So in our case, what SMOTE we have to use? Because all our independent variables are categorical, right? All our independent variables are categorical. So we have to use SMOTE N. Because in this data, all the variables are categorical in nature. From Imbalance, NC. NC is there, no? NC is for both numerical and categorical. SMOTE plain is for only numerical. SMOTE N is for only categorical. Independent variables. Independent variables के बारे में बात कर रहे हैं हम लोग. See, dependent तो non-numeric category होगा ना? There is no change there. Our dependent variable in classification will be non-numerical and categorical, binary or multinomial. We are talking about independent variables here. Independent variables, if they are only numerical, use SMOTE. If they are both, then NC. If there is only one categorical variable, all are categorical in nature, SMOTE N. This is a oversampling technique. Oversampling dot import. See here. SMOTE, SMOTE-NC, SVM SMOTE is also there. You can balance data in support vector machine also. In support vector machine algorithm, there is a sub-argument called balance is equal to true or false. If you say balance is equal to false, it will take it as imbalanced data and it will balance it. SVM algorithm has inbuilt balancing option. That is SVM SMOTE. But otherwise, you have SMOTE, SMOTE-N and SMOTE-NC. So what we are using here, SMOTE-N, because all our independent variables are categorical in nature. Logic underscore SMOTE-N is equal to logic dot fit. Oh, sorry. SMOTE-N is equal to SMOTE-N. Random state is equal to 42. One second, let me check once. X underscore SMOTE-N, comma Y underscore SMOTE-N is equal to SMOTE-N dot fit underscore resample X comma Y. आप इसमें नहीं है SMOTE-N. आप एक काम करो, OS अपडेट करके एनाकोंडा अपडेट करो एक बार. So print Y dot value counts, print Y underscore SMOTE-N dot value counts. So it's oversampling technique, 21,033, 21,033. Logic underscore SMOTE-N is equal to logic dot fit X underscore SMOTE-N, comma Y underscore SMOTE-N. Logic underscore SMOTE-N dot score is equal to X underscore SMOTE-N, comma Y underscore SMOTE-N. 82, it has increased, see? The accuracy has increased. Let us see the other metrics also. SMOTE-N underscore predict is equal to logic underscore SMOTE-N dot predict X underscore SMOTE-N. Print classification report Y underscore SMOTE-N, comma logic SMOTE-N predict. See, everything increased to 81. So SMOTE has a very good implications in imbalance data. Most preferred algorithm in imbalancing data in industry. So this is the SMOTE-N. It is giving a warning. Next time onwards, you have to use keep dims is equal to false or true. Then you can see the value counts 21,033, and then we build the logistic regression. Upper here. Hmm? Yeah, you'll take a break. You can take your break.
So if we have test data should also less SMOTE and then very from the
Test data, in this case, we don't have the dependent variable. No? That's what. Here in this test data, we don't have the dependent variable. But if you are creating your own test data from trained data, you are creating the test data from trained data, then you will have dependent variable, right? Train underscore test underscore split. There's a function called train underscore test underscore. See, in this case, this is a competition data. Test data is already given to us. So we don't need to do any balancing because we will directly predict. But if you are creating test data from your own train data, train underscore test underscore split with random state and 20% as a test data, then you'll have a dependent variable. Then the dependent variable might be imbalanced. Then you have to run SMOTE on the dependent variable also. Then only you can do the prediction. Getting it right. If you're creating your own test data, then you have to do the SMOTE on test data also. Train underscore test underscore split. See, we are using, because we are working on competition data sets, we are not creating our test data because it is already given. But if you are working on normal textbook data sets, you have to create your own test data using the train test split. Okay, HR analytics, we can do that. Or we can do any other data. So train underscore test split means you are creating your own test data from train data. In this case, the test data will have dependent variable. Will have dependent variable. So you have to use it. So that is one way of looking at it. Textbook data sets, we do that, but we are working only on real-time data sets. And in real-time data set, the test data does not have a competitions having no predictable variable. So we'll do that. So we are directly using it for predictions. Okay, can I scroll down? आप एक काम करो, you run SMOTE only. Plain SMOTE run कर दो. Update करा. कौन update all? Formula space update space 2 hyphens, 2 dashes, all, and then you get all the list of items. Then you press Y and small y, it will update only. You do it every month. Formula update from within. Open the terminal or command prompt or icon prompt. Formula space update space 2 hyphens or AN. It will give you the list of items. Then press Y. It will update all the libraries. So you can take your break. Online guys, any doubts?
No, sir.
Okay. Conda space update. Update space double hyphen all. Double dashes all. Two times you have to give the dash and the all, ALL. Terminal. Apple में terminal. You have terminal, no? Terminal में करना. Click on terminal. It will ask for, you can open a new terminal window here. A new terminal window खोलो. Right click on that terminal, new window here. Conda space update space 2 times hyphen all. So it will get all the packages that need to be updated so that you can at least once a month see. वो नहीं, उसमें राइट क्लिक करके न्यू विंडो खोलो. नीचे है ना, नीचे टर्मिनल आइकन पे राइट क्लिक करके न्यू विंडो खोलो. वो लिस्ट ऑफ पैकेजेस आएगा, उसके बाद वाई मार के एंटर मार दो. सर न्यू टर्मिनल विंडो खोल के उसमें करो, इसमें मत करो. ये पाइथन का जो टर्मिनल है उसमें न्यू विंडो खोल के कोंडा अपडेट स्पेस देके अपडेट हियर ये देखो कोंडा स्पेस अपडेट स्पेस 2 dashes 2 hyphens all ALL. Enter. So Conda update double hyphen all. You can do it in Anaconda prompt, or you can do it on your normal command prompt also. Because we have tick marked that thing, no? When you are installing, you have tick mark that add thing. So you can do it in normal command prompt or Conda prompt, Anaconda prompt. But do this every month. Every month, once you have to do this. See, so many packages are updating now. These are all libraries which are updating now. So that way your Anaconda will be updated with the latest libraries. When Anaconda gets updated completely, then you have to install the new version. I think next version is 4. 4 will come next 2 months. Then you can install the new one. You got the list? Y type करो, small y type करके enter करो. Y type करके enter करो. Then libraries will start installing. हाँ 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 सब बाइनरी पे. See, इसका भी बैकएंड प्रोग्रामिंग जावा ही है. पाइथन का बैकएंड प्रोग्राम जो है जावा ही है ना. हाँ वो भी बाइनरी कंपाइलर है ना. हाँ जावा का बैकएंड प्रोग्राम C and C++, both I think so. Both are there. So once you have done all, will get like this. Then you'll get your base and a percentage, and then you can close the terminal. अभी जरूरत नहीं है. See, abhi kya hai, now you don't need programming. There are automatic coders which are developed by artificial intelligence and natural language processing. So you simply say, write a program for adding two numbers. It will write a program and give you in whatever language you want. C, C++, Java, sub. You can write the program. Huh? That's what I'm telling you. Na? You type it in English, it will write the code. Python का भी है, SAS का है, सबका है. Unix, C, C++. So what happened is compilement of all the programs. Backend में machine learning ही है, NLP and machine learning ही है. वो पूरा programming codes को historical data लेके they built an algorithm. And that algorithm will give you any program you want. So requirement coding is going off. Maybe 2-3 down years, no need of anything. Like अभी Python में कोई coding नहीं. When I started Python for the first time, average calculate करने, mean calculate करने के लिए I have to write a loop. अभी क्या है? Dot mean. You'll get it for the whole data frame. You'll get it for single variable. You can do anything with that. You can add it in any programming part. For loop में add कर सकते हो. You can do anything with it. So that is the comfort level. Cannot, one second, cannot import. Okay, no problem. आपका version में problem आ रहा है. Okay, we'll look at it. Yeah. Done? Python is faster compared to Java. See, it all depends on the program you're running. It all not the programming language. Processing speed के लिए Python के लिए चाहिए. Because Python is a function-oriented programming. Obviously, it requires a little bit higher computing. See, Java is a core programming language. You are writing it in a step there. Here you are writing in functions. Function के अंदर code रहेगा. Code, if you are using 10 functions, that means you will have 10 different codes. So it will obviously require a little bit of processing compared to Java. Java में क्या है कि वो length of code ज़्यादा रहेगा, processing time कम रहेगा. But Python में क्या है कि length of code कम रहेगा, processing time थोड़ा ज़्यादा रहेगा. Not much, little bit in microseconds and nanoseconds. That's all. That's why people are running after Python, right? Because it has very high advantages in time benefits. Time benefits बहुत है उसमें. Complex coding को भी आप size कम कर सकते हो, and you can run it faster. And you can adapt it to any programming language. C, Java, जो भी है, you can connect it. Yeah. But Python, see, they made it as independent. C, Java hai, but whatever you are getting in a Python environment like Anaconda, they are predefined. Agar aap original Python, if you're using original Python, base Python, then you have all those problems of Java and C. In Anaconda Python, everything is integrated. Java and C is also integrated into Anaconda Python. So Anaconda Python is a full Python with all the libraries pre-installed. Pre-installed means all the requirements that are required for you to do a data science project are all there in Anaconda Python. That is why we are using Anaconda Python. If you are using base Python, you have to install NumPy, Pandas every time. Every time you have to pip install, every time you have to do it and all. We don't do that in Anaconda Python because Anaconda is a preloaded environment with all the required libraries. So that is where Anaconda has gained advantage. Now there are some competitors coming for Anaconda because they have a monopoly now. Now there are new people coming into the market that are offering all the libraries into predefined environment. Like Google Collaboratory. Google Collaboratory, you don't need to install also, right? It's a competitor to Anaconda Python. Collab, you don't need to install. Just collab maro, start working. All libraries are pre-installed. PyCharm. PyCharm also fully loaded version of Python with all libraries. We will work on Python. Huh? With libraries. So there are a lot of things here. There is Golang. Golang is considered faster than Java. But that is, see, faster कब चाहिए when you're running complex applications and time is a factor. जब time is a factor, जैसे stock market में है. Stock market में time बहुत बड़े factor है ना. Because seconds में prices बदल जाते हैं. Bitcoin में seconds में prices बदल जाते हैं. तो वहाँ पे क्या है कि time is a factor. There you need high speed. But when you're running a model for decision making, you can have time. Loan approval के लिए you need not approve loan in 1 minute. You can approve the loan in 24 hours. Right? Loan approval can be done in 3 hours, 4 hours. So what is the speed requirement there? So it all depends on some time complexity things are there, like stock market trading, online betting, video games, gamings, then your what you call operations like flight operations, aircraft operations, and all those things where you have to take very, very fast decisions, right? So there you use them. Online betting is very, very big business. It's a very, very big business. Yeah, Dream 11, it's illegal in India, but government is promoting it. Telangana government blocked it, right? Dream 11, you can't, Telangana blocked it. Dream 11 is what? It's a betting app. MPL. That is purely house always wins. MPL. How many apps came? All illegal. Government is saying them as startups. Government is promoting them as startups. Ad be all of them. Right? उसमें बहुत पैसा है. You know, Dream 11 is partly owned by Mukesh Ambani. इसलिए उसको government support है. जीतना नहीं होता है. 10 में 2 बार जीतोगे तो 8 बार हारोगे आप. हाँ. 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 वो भी बिजनेस है. जैसे there are apps that will help you to win. मतलब आपको विन करने के लिए वो देते हैं. उसको आप पैसा पे करोगे ना, वो ट्रिगर भेजेगा. नाउ यू पुश बाय 60 seconds बाय, आपको पैसा मिलेगा. पैसा वो दिन में 10 बार देगा. 5 बार सक्सेस होगा, 5 बार फेल्यूर होगा. आप 5 सक्सेस पे इफ यू इन्वेस्ट मोर, यू विल गेट मोर मनी. देयर आर दैट एप्लीकेशंस आल्सो हु विल हेल्प यू टू विन. बिटकॉइन पे है, बहुत है. वो एक्स ट्रेड कुछ है, वो एन एक्स ट्रेड कुछ है, बहुत से एप्स हैं. सो वहां पे ये एल्गोरिथम्स बहुत इंपॉर्टेंट है. These algorithms are very, very important in that situations. Time complexity. All the applications, betting apps जो भी इंडिया में चल रहे हैं, सब business families own करते हैं indirectly. Ambani, Adani, all of them. They all have this money. Film stars, सब लगे हुए हैं. All because of Lalit Modi. IPL, yeah. Why do you think IPL was created? To do the betting. अभी क्या है? तमिलनाडु IPL है, तेलंगाना IPL है, आंध्रा IPL है, कर्नाटका IPL भी है. Look at the way they are increasing the bettings. हाँ. हर स्टेट का IPL है. हर स्टेट का IPL है. यहाँ पे भी है, तेलंगाना IPL है. इंटर डिस्ट्रिक्ट क्लब्स है, बेचते हैं और खेलते हैं. नहीं, वो नहीं है, ये IPL है. तमिलनाडु IPL है, AP IPL है. AP IPL चल रहा है और तेलंगाना IPL अब 2-3 महीने में स्टार्ट होगा. सब बेटिंग के लिए, सब बेटिंग के लिए. खो खो टूर्नामेंट्स, कबड्डी टूर्नामेंट्स, आप जो भी करो, They are all betting. और betting में क्या है कि how to predict the odds. Odds बोलते हैं ना, logistic regression use करते हैं. उसमें purely logistic regression use होता है. Odds 50%, 40%. 50% of winning, 40% of losing. 60, 40, 70, 30. उस तरह का odds will get. That's all. Yeah. Very good. Data is very, very interesting and very, very dangerous also. आपको पैसा भी देता है और आपको लूटता भी है. कहाँ पैसे चले जाते हैं, वेस्ट मत करो. इंजीनियरिंग वालों को लग गया सब. दे टारगेटेड द इंजीनियरिंग स्टूडेंट्स. Yeah. 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 That's what. I'm telling you now, the house always wins. मैं भी कैसे में खेलता हूँ. With knowledge that house also wins, we'll go. But what we have to do is, we'll try to predict it. Random numbers predict करना पड़ता है वहाँ पे. Randomness में betting में भी randomly predict करते हैं. कुछ भी हो सकता है. कुछ भी हो सकता है ना. When your randomness matches, you will win. वो random match नहीं होता ना. So popular undersampling technique. Undersampling. So SMOTE is a oversampling technique. SMOTE is a oversampling technique. So popular undersampling statistical technique is Tomek links. Tomek links is a popular undersampling statistical technique. Tomek links are pairs of very close. आप एक काम करो, गूगल कोलैब पे चले, वो नोटबुक इंपोर्ट करके कोलैब में ओपन करो, चलेगा. वो आप इंपोर्ट कर दो IPNB फाइल, फिर उसको आप कोलैब का फोल्डर है ना ड्राइव में, उसमें डाल दो. कोलैब में ओपन करके वो डेटा जो भी है गूगल ड्राइव में डाल के उसका लिंक देके आप चालू करो, वहाँ पे हो जाएगा. कोलैब में हो जाएगा. हाँ, फर्स्ट डाउनलोड नोट करो, मैं हेल्प करता हूँ. ठीक है. Tomek links are pair of very close observations that are on the opposite sides. That are on the opposite sides. It retains the minority class and removes majority class observations. It retains the minority class and removes the majority class observation. It increases the margin between classes. So Tomek links is an undersampling technique. SMOTE is a oversampling technique. So Tomek links, by visualization you can understand. So you can see here, very close observations it will identify, and it removes the observations of the majority class and retains the minority class. So, ये GCP में थोड़ा गोल कर रहा है। पीछे scroll down करो। इसको double click करो। डेटा गूगल ड्राइव में गूगल ड्राइव अपलोड करके फोल्डर डाल के वो ड्राइवर से ड्राइव का पास कर देंगे ये इनको भी डाल के यहाँ पे ड्राइवर के पास कोलैब में जाके कोलैब में फोल्डर उसमें तीनों फाइल डाल फिर उसको काट देना ये रिमोट ये इसकी जरूरत है तो यहाँ पे सीधा पास होगा तो पहले गूगल ड्राइव को ड्राइव को ऑन करके यहाँ पे कोलैब पर अब डेटा पहले माउंट होगा सर माउंट हो गया नहीं हुआ ड्राइव आना चाहिए ये रन करो बोल रन करो वो माउंट करेगा ड्राइव आना चाहिए कनेक्ट हो अच्छी तरह वो बोल नहीं सकते बाकी मेरे को देखना पड़ता ना तो बाकी मेरे में शुरू देखना पड़ेगा तो अभी आप ड्राइव माउंट कर दिया ड्राइव दे दिया अभी आपको गूगल करके ड्राइव में कोलैब में ड्राइव में डायरेक्ट फोल्डर वो ये नहीं वो दूसरे फोल्डर नीचे यहाँ पे अपना कॉपी फाइल अपलोड can you press अपलोड होने के बाद उसमें जाके पार्ट कॉपी पार्ट कर दो और रन लॉग कर दो और पिप इंस्टॉल इम्बैलेंस भी करना है पिप इंस्टॉल करना पड़ेगा इम्बैलेंस. Okay, so Tomac links, as you see here, green is the minority class, blue is the majority class. It identifies the close and it starts deleting the blues. Blues को delete करेगा, greens को retain करेगा. Thereby, number of blues will come down. This is an undersampling technique. Undersampling में deletion होता है, oversampling में addition होता है. So this is what happens with Tomek links. This is a popular technique in undersampling. If you want to use an undersampling technique, statistical model, Tomek links is the undersampling technique. So from Imbalance dot undersampling, import Tomek links. Tomek is equal to random undersampler sampling underscore strategy is equal to majority. X underscore Tomek comma Y underscore Tomek is equal to Tomek dot fit underscore resample X comma Y. Because there is no Tomek function here. Now, oh, we have Tomek links here. We have Tomek links. Why I'm using random undersampler then? Sorry. Tomek links, sampling strategy is equal to majority. So we are resampling only the majority classes. Or resampling is auto. By default is auto, or we can give auto also. What is that? It will automatically take the majority class. Sorry, I have used wrong random sampler. We don't need to give any sampling strategy. So print y dot value underscore counts, print y underscore Tomek dot value underscore counts. Right. Oh, it did not reduce it. So we have to give a sampling strategy. Actually, no nearest points come rehte hai na. It might have smaller nearest points. So अगर sampling strategy minority दिया तो कैसा होगा? हाँ, see, it cannot be used. All देते हैं. So वो closest observations नहीं है तो वो कर नहीं पाएगा ना. It needs closest steps. हाँ, so it needs to find this close observations. So close observations कम रहेंगे तो sampling भी कम आएगा. Pairs only. Pairs रहना चाहिए नजदीक में. Otherwise it will not be able to do it. So sampling strategy majority तो पेयर्स बहुत कम है इसमें। Logit underscore Tomek is equal to logit dot pair. Let us see. $84.55. Imbalance. Imbalance here. So there are no pairs are not available for doing the sampling. इसमें क्या है कि pairs available नहीं है sample करने के लिए. That's what, not much used. SMOTE is the preferred. Or use random undersampling. It's a academically textbook algorithm, that's all. Depends on pairs of data. अगर pairs है तो होगा, pairs नहीं है तो it can't do. Like what is happening here. Yes. Yes. So SMOTE is good. SMOTE is our good one. So now you can build all other algorithms on this imbalanced data and predict on the test data. Which one? Nothing. It is already balanced, right? So let us say I want to predict. Logit test predict is equal to logit underscore SMOTE dot predict vaccine test DM. Test data पे ना PD dot data frame logic test predict comma logic dot CSV. Hmm. H1N1 dot CSV, right? Now, if I go to the hackathon folder, H1N1 vaccine prediction, logic season CSV is also there, no? We have predicted earlier logic season. Open with Microsoft Excel. Logit H1N1 is open with Microsoft Excel. Logit H1N1. Logit season. Okay. And then sample submission. Okay. So here we need to predict the probabilities. So we need the prediction of probabilities. So predict underscore proba. I'll keep the sample submission format. I'll do this, I'll go to this. Okay. Plot. Okay, 0 and 1 का prediction आएगा आपको. Okay, so both predictions आएगा 0 or 1. So we will take आपके पास सैंपल सबमिशन फॉर्मेट है, एक बार देखो क्या दिया है उस सैंपल सबमिशन फॉर्मेट में. So 0.5 and 0.7. So probabilities चाहिए. Okay. So what we can do is we have to do probability prediction. Now this is a binary only, not multinomial. So what we have to do is इसका prediction हमने दिया हुआ है. Logic SMOTE का prediction हमने H1N1 में दिया है. Okay. So you have to open the CSV file. इसमें 0 and 1 है ना. So एक ही का क्लास ले सकते हैं हम लोग. इज इक्वल टू मैक्स ऑफ दिस टू. So we got the max probability. Okay. Then we will reduce the decimal. मैक्स लिया है दोनों में से. ओके. तो क्या करेंगे? सैंपल सबमिशन में प्रोबेबिलिटी देना है. So what it says is in this sample submission, see, you will be predicting two probabilities, one for H1N1 vaccine, one for seasonal vaccine. Probabilities predict करना है. 0 means no, 1 means yes. Then submission format here. See here. The prediction of the two should be float. Probabilities that range between 0 and 1. Because the competition uses ROC, AOC as its evaluation metrics, the values you must submit must be the probabilities that a person received each vaccine, not the binary variables. So received each vaccine. उसका मतलब हाँ वो S की probability लेना पड़ेगा. Only S का probability लेना पड़ेगा, बाकी सब कुछ नहीं है. So we will take only S probability. That's what we did earlier also. So ठीक है, submission format है ना, इसके नीचे ही है H1N1. So S का probability ले लेते हैं. Control C. ये H1N1 का है ना, यहाँ पर paste values and number formatting. And then we will put it as 2 decimals. Okay. Same अभी seasonal vaccine का भी निकालना है. Seasonal vaccine का कोई problem नहीं है. नहीं अभी करेंगे ना. Logic underscore seasonal is equal to logic dot fit vaccine reindeer comma vaccine labels dot seasonal vaccine. Okay. Logic underscore seasonal dot score. Vaccine trained here. Yes, same thing. 77.50. Logic underscore seasonal underscore predict is equal to logic underscore seasonal dot predict underscore proba underscore proba. Vaccine test DF. Vaccine test DF. PD dot data frame logit underscore seasonal underscore predict dot two underscore CSV logit seasonal dot CSV. Okay, so I will get the logit seasonal CSV also here. Open with Excel. Okay, इसका भी 1 का probability लेंगे हम लोग. इसमें paste values and number formatting. Number में जाके 2 decimal करेंगे. Control yes. Sample submission format. ये logistic regression का sample submission format है. So let me submit and see if it works or not. Submissions. Make new submission. Choose file. Desktop. Hackathon. H1. Submission format. Open. Begin upload. So the metric is not accuracy, it is AUC, area under the curve. Your score for the submission is 0.2615. Why worst? This is AUC, na? So best is 60, yeah. My best is 60. That is because of the GBM or anything. 2615, the base model hai na ye to. We have used the base model, logistic regression. If you use advanced models, no, area under the curve. Under the curve. AUC is different. ROC, area under the AUC matlab area under the receiver's operating curve. Actually, it is AU ROC. Area under the receiver's operating curve. Uska formula ye hai. TPR, FPR, false positive rate and TPR. So the formula is little bit complex. So we will see this. We need true positive rate and false positive rate. Concordant pair, discordant pair. ROC curve. अरे अभी खत्म हो गया. We were doing na plot ROC curve in other these things. You will get a curve like this. The formula is little bit complicated. This should help us. किसको चाहिए check See here. So it's a very complex thing, but it uses TPR and FPR, true positive rate and false positive rate. And then it uses them to calculate over multiple iterations. This is the formula 1 epsilon to the inverse 1 minus probability of false positive. And this formula is used to calculate the AOC ROC curve. So use the here the competition is using AOC ROC curve. Here we can get a good formula. So the AOC, the higher the better. This competition is using, this is the formula. Hey, what is this one? So this is what function, no? No. This symbol is what? Limit, limits, right? Limit from infinity to negative infinity, minus infinity. TPR of t multiplied FPR derivative of FPR t dt. Integration, right? Integration, yeah. I forgot mathematics already. Last 1 year I didn't teach maths paper, no? So I didn't have time. Generally, I teach maths paper somewhere or the other. Mathematics for data science, where we talk about integrations and derivatives, differentiations, then matrix calculations, inverse matrix, then what you call theorems, matrix theorems, integration theorems, differentiations. So this is how you have to do. So the probability is predict underscore probability. Participants use predict underscore probability. Yeah, it's all +1 +2 maths only. 10th plus 10th, 11th and 12th maths. That is what data science needs. Basic mathematics is all from there on. So take the probability of 1 only. You will take the probability of 1 only. Column which represents 1. That is the one you will take. So predict underscore proba for both seasonal underscore vaccine and H1N1 underscore vaccines. You have to do 2 predictions. Take the 1 predictions probabilities, paste it into submission format and upload it into competition site. Okay, so then you can get your score. So if you want, you can take this as your capstone project for classification. Seasonal और दोनों का submit कर सकते हो. Capstone submit करना है ना, classification का भी. Your choice. Season का भी अलग से है ना notebook. वो notebook और दोनों notebook इसमें भी you have to do is build all other models. Decision tree, random forest, all models, naive Bayes, KNN सब करके इस H111 में भी seasonal में already we have done. Seasonal we have built all the models. Here also you build all the models. और predictions को copy करके upload करते जाओ. You will get your scores and submit it as your final project. And you can put it as a GitHub project. This is very interesting. ना imbalance भी आप deal कर रहे हो तो it has value addition ज़्यादा रहेगा. So this should be your classification project. Real time data है ना. You can take it as a real time classification project. Healthcare analytics comes under healthcare. Healthcare में बहुत से jobs है. Patient data पे, informations पे, medical records. Huge. हाँ वही probability of one ही चाहिए ना. What he is saying? He says we want the probability of only the people who have taken the vaccine. What is one? People who have taken the vaccine. One represents yes. So what the problem statement is, take the probability of people who have taken the vaccine, which is 1. So when you do predict underscore proba, you get two predictions, two probabilities, 0 probability and 1 probability. You will take only the probabilities of 1. Summation of both will be equal to 1. Summation of both the probabilities will be equal to 1. Online guys, any doubts? I sold it off, no? Cashify. I got hardly 19,000. 19. Mac में वही problem है. Resale value कम रहता है. It's a resale value बहुत कम रहता है उसमें. 19,000. अच्छा. हाँ. I didn't realize. तो Cashify में मैंने book किया था slot. तो ultimately हमेशा Mac का वही problem रहता है. Because that is a 2011 version ना. Model पुराना है. Mac का update अभी हुआ है. Same M1 chip था ना. हाँ M1 chip था. M1 chip का ही 19,000 मिल रहा है. अगर normal Intel chip था ना 10,000 मिल रहा था. हाँ same वही है. हाँ फिर भी मॉडल एग्जिस्ट फ्रॉम 2011 ना. तो इसका आप चेक कर सकते हो. 20 अगर आप थोड़ा मेहनत करके बाहर जाके बेचोगे तो 25 में मिले मिल जाएगा. हाँ 20-25 में मिल जाएगा वो. कैशिफाई में गॉट 19,000 कूपन के साथ मिला के पूरा 20,000 आया था. 500 को कूपन था. हाँ मैंने M2 ले लिया. वो अलग से बेचा ना. वो अलग से बेचा. ये मैं रिलायंस डिजिटल में ऑर्डर किया था ऑनलाइन में. उस टाइम पे शॉर्टेज था ना. इट वाज शॉर्टेज.